already discussed some aspect on anaerobic digestion model in our last class. Actually, we are just simply recapping you the different process involved, and this was the process. So complex polymer to monomer oligomer, then from this one they are producing hydrogen volatile fatty acid acetate. One group of microorganism is producing hydrogen carbon dioxide to acetate, and methane production is done by two groups of microorganisms. So this is a really complex model. In our last class we have seen that we can actually simplify without considering all those complexity. Now this class will be focusing on how to deal with this kind of complex model, how we represent it, and how should we model, what are the different parameters involved. Those aspects we'll be discussing in this class. Let's see how you are doing. The first step, we'll be doing it stage wise. First step is actually, as I told, from insoluble substrate hydrolyzing microorganism is involved, which is producing soluble substrate. So essentially this is the first step of reaction, and it will have two different parameters. We already shown you, if you are using Contois kinetics, then Kx and Kh will be involved. So once we have soluble substrate, then this is the one stage. We are putting it a stage wise manner just for better understanding. So I know this is the variable, that is our substrate, and the soluble substrate can be converted by acidogenic bacteria into hydrogen carbon dioxide acetate. So three compounds they are producing together. And if we are doing like this, we should also know what are the yield coefficients associated with them. So we are assuming hydrogen production yield with acidogenic bacteria is YH, one parameter. Similarly, acetate production is acidogenic bacteria, how much is acetate is produced. So yield coefficient terms, which talks about biomass with their products, biomass ratio to product ratio. So this is the yield coefficient you normally use. This is the second part, the second stage, the part A, and we can have part B also, where acidogenic microorganism can hydrolyze some of the substrate into volatile fatty acid, or VFA, that we have already seen. Some of the soluble substrate can be produced into volatile fatty acid, and if it is produced, it is also having some of its associated parameters. We can see in the whole block that some of the acidogenic microorganism will have its specific growth rate. The KSB is for substrate consumption kinetics, then you will have KSP. Mu MACD is maintenance consumption of substrate, SB, when acidogenic bacteria is growing, maintenance energy requirement. Yield for biomass YX acid by SSB, so substrate consumed, how much acidogenic bacteria will be produced, and what is the VFA produced per acidogenic bacteria growing. So these are all parameters for this model. So when we will be writing for substrate consumption or acidogenic bacteria, we should keep into this thing in our mind. So this is one stage of our anaerobic digestion process. Then next step, we will have acetogenic bacteria, which is actually producing from volatile fatty acid to acetate. So VFA to acetate production is done by acetogenic microorganism. We are assuming like this. It is not necessarily it is the only way the reaction will happen. Now for acidogenic bacteria, same sets of equation will come over here, because the same stage, you see, mu max of acidogenic bacteria, how much of hydrogen produced by acidogenic bacteria, yield coefficient, VFA, KVFA, because VFA is the substrate. So when you are modeling the growth, so mu max into VFA divided by KVFA plus VFA. So this is the substrate model we need. Maintenance requirement for acetogenic bacteria. So total VFA consumption will be depending on how much is utilized for growth and how much is utilized for maintenance. Now acetate production from VFA, that is the yield coefficient, how much of acetate per mole of VFA, and this is how much of acetate is producing per x ace, that is acidogenic biomass. Ace is acetate by acidogenic biomass, VFA consumed by acidogenic biomass. So this is for substrate consumption terminology, yield coefficient what it will say, and this is product formation type yield coefficient. So 1 2 3 4 5 6 parameters will be involved when you are going to write the expression for these small steps. Then we will have the last part of the equation where hydrogen and carbon dioxide is going to be converted into methane by one group of methanogenic microorganism, that is hydrogenotropic microorganism, and you know will be the parameter here involved, which parameters. So similarly, as you can see 1 2 3 4 5 6, here also 6, any kinds normally will be 6. So 1 will be for methane production from methanogenic biomass, so product yield coefficient, specific growth rate, Ki may be the inhibitor constant, KACE is for acetate consumption, acetate based microorganism for inhibition terms, methanogenic terms, and here X methanogenic microorganism, the same microbial population when it is producing methane. And the second part will be only related to hydrogen part. Hydrogen part will be, actually the drawing is something opposite. Hydrogen part will be methanogenic production from hydrogen, methane production using the methanogenic biomass to maximum biomass growth, or max, maximum specific growth rate from hydrogen carbon dioxide component. KH2 is for hydrogen utilization, and this is maintenance requirement of the microorganism when we are talking about hydrogen part. So essentially we are talking about substrate is SiB, Sp, VFA, acetate, hydrogen. We are not talking carbon dioxide because hydrogen and carbon dioxide is proportionally utilized. So these, and methane. So these are the actually substrate things. And biomass, one class biomass, second biomass group of acidogenic, which is being utilized twice. Acidogenic microorganism we have assumed only once. Methanogenic groups are two class, one is for using acetate, another is going for hydrogen, they are producing methane, and each of them group has their own maximum specific growth rate, yield, substrate consumption, and product formation. Substrate consumption, product formation, monode constant K will be there in all those, KSB, KVFA, KH2, similarly KACE, acetate, that is for those aspects. Some inhibited terms may be there if we assume any inhibition is there. And somewhere we have used also maintenance, you see maintenance of ACD, acidogenic biomass maintenance, similarly acetate maintenance, similarly methanogenic biomass maintenance. It is not necessary. We assume that even if the microorganism is not growing, they will consume some substrate. So substrate consumption can be written not only as a proportional to growth plus maintenance into biomass concentration. So even if they are not growing, they are taking food. So in that case we need to modify the expression in the same way. So first thing is that you need to understand how we are going to get the whole structure. It can be simplified. We can, for example, you can ignore the inhibition things, you can ignore the maintenance things, you can make it simple, that is your choice. But basically those other terminologies will be generally there. So these are actually really big model. You see we are having a lots of parameter to be estimated, and what we can measure from our experiments, we can possibly measure the insoluble substrate concentration in our experiments, we can measure soluble substrate concentration in our experiment time. Volatile fatty acid can also be monitored in your bioprocess. Hydrogen monitoring will be really difficult, but we can measure, and methane concentration we can measure. So these are the profile we can really have from experiments, and this is the model structure we will prepare, and we can do the simulation to find out, and parameter estimation to find out those parameters. But why we have shown this kind of approach, there is a reason behind that. The first reason is that this hydrolysis, even if we are not going for anaerobic digestion, so the first block, these blocks does not depends on the next round of blocks. So Kx and Kh we can estimate without doing the whole analysis, because it only depends on all the parameters. It does not depends on the subsequent steps. So if you know Kx and Kh by simple one experiment, if you are doing with insoluble substrate, how much soluble substrate is produced, we can do that. So that will give us a clear idea. Of course, we should not have any acidogenic microorganism or methanogenic microorganism. We should not have in this batch. Now similarly, when we are talking about soluble substrate and production of maybe for example acetate, we can do that. So we can take some, for example, simple substrate like glucose, and we are only taking acidogenic microorganism, we are not taking any methanogenic. So we can do those steps. We can also simplify this whole block of analysis. We can simply do by only taking acetic acid as our substrate. If we do one experiment with only acetic acid, and we are having only two kinds of microorganism, this one and this one, and we are running one experiment, so what will happen? Our block will be only this. So this is our experiments maybe, and if we do the experiment using only acetic acid, these are the only parameters, only for example 4, 5, 6, 7, 8 parameter only. So it will be more easy for estimating these 8 parameters separately using only acetate, because by the way these parameters are only acetate dependent parameter we can do, and if you are doing only acetate, then 1, 2, 3, 4 is only sufficient. That's all. There is no hydrogen or carbon dioxide. So it is more easy if I am taking the microorganism, same seed sludge, same microorganism, but we are only doing with acetate. So these 4 can be very easily estimated. So you need to understand that rather than doing the whole block of experiments, we can do in small block. We start with acetate, so before acetate nothing is coming into picture, we can really ignore, only this part will be our valid. We can do, it is more easy. Similarly, we can also do with hydrogen and carbon dioxide steps for production of this one, it is possible. Similarly, we can do with some VFA, volatile fatty acid, we can start and we can find out what is the efficiency of producing acetic acid without any methanogenic microorganism. We can inhibit the methanogen because they are strictly anaerobic. So that procedure we can also do, and we can find out those parameters if we perform experiment like this. If we start with soluble, then we can ignore this, only this is our whole block, only this. So depending on, we can segregate the experiments and do the parameter estimation and modeling analysis. Now I'll show you how we are going to really have the model equation, because it is really complex. There are so many things how to do. So you should have some strict policy on that, and I will show how you should deal with these kinds of modeling and how it is becoming easy and effective. So first thing you should always keep in mind, write all microbial growth rate. It's more easy. It depends on substrate and product, if any inhibition, if you are assuming, or you may ignore. So it is more straightforward to write the microbial growth equation rather than substrate consumption. We can do the substrate consumption, all those things later on. So first thing you should always suggest to do the growth related equations. For example, see we have written for acidogenic microorganism, we are assuming acidogenic microorganism is growing on soluble substrate and they are getting inhibited by VFA. So it is straightforward, because acidogenic microorganism is only consuming the soluble substrate. So this is up to this point, it is a monod equation kind, simply. So what is the substrate and who is growing, that is information is required. So acidogenic microorganism is growing on soluble substrate. We have added this inhibition term because we assume that VFA can be inhibitor. So it is straightforward, we can write. We can have a different kind of equation depending on what kind of kinetic model you are assuming, but it will be like that only. Now we will do it for all other biomass also. Now next step of our thing is to do the substrate equation. It is little complex, but if you understand this objective, it will be very easy. Each substrate equation except for the first substrate and the last product, all the intermediate, everything will have two components of its equation. one will be its production and another one will be for consumption. So any intermediate is produced from earlier equation and being consumed in the next equation. So we can write it more simple way. We're talking all those kinetics assay for anaerobic digestion. Let's see simple one. For example, any intermediate stage, this is the intermediate compound S4, for example, some intermediate substrate or product, and it is being produced from another substrate I have not shown by microorganism X1, which is being consumed by another microorganism X2 and producing some other products. Forget about that, only talk about here now the three things, this one and this one. So one microorganism before that, another microorganism after that, and S4. So how to write the equation for S4? So it will be more simple. You see, S4 change is coming up because X1 microorganism is growing, it is doing something on its earlier substrate, so that's why it is producing. So production will be proportional to growth of the earlier microorganism, alpha dx1 dt. Alpha is a constant I am assuming. So as much as X1 is growing, same proportionally S4 will be produced, but S4 is consumed also. So if I want to make a balance, how much is remaining, how much is changing. So for X2 also you have to do the same thing, that is beta into dx2 dt, because this X2 microorganism actually consuming the substrate. So all substrate, whatever you have seen, it may be volatile fatty acid, it may be hydrogen, or it may be soluble substrate, everywhere there will be two part. One is producer part, which is actually positive number, and another is decreasing consumption. So production and consumption, if you make a balance for all substrate, you can write out. So it is really straightforward. For substrate you need to take two microorganisms before and after, and for microbial growth only we need to focus what is its substrate. So if you have these two things in your mind, making a dynamic model is really straightforward, and you can do it for any number of equations, as many as we have. Finally, you have to keep in mind if you have completed it or not. We have to write as many as equations depending on how many substrate and products and microorganisms. If there is 7 substrate and product, and for example 5 microorganisms, so you must have 7 plus 5, 12 equation. You should take care your equation, total number of equation, differential equation must be 12, so that you can complete the anaerobic digestion process, or you can make the modeling more effectively. Any doubt and queries you can write to me.